Hello again. It's Mr. Alexander coming at you with more trigonometry. Building off of what we've already learned about SOHCAHTOA, the purpose of the lesson that we did, I guess it was March the 18th and the 19th, right? Was we took that information and we thought, is there another way to find the area of a triangle? Because if I give you a couple sides, like this side here, AB is 20 units long, and this side AC is 15 units long. So neither one of those is the height. That would be this thing here. But then, of course, we could think of 20 as the base of that. So we could say that if the base is 20, and we could just figure out the height somehow, then we could find the area of that triangle by doing 1/2 times the base times the height. Right? So we could plug in the number 20 for the base. We just need to figure out the height. But if I know this angle here, I have enough information to use trigonometry to figure out the height. And so the first step we asked ourselves was, okay, well, then what trig ratio would we use? Let's think here. First of all, that 20, well, here, I think I got ahead of myself. Notice that the height, when you draw it, it makes a right triangle. That's a really important thing to notice. Before I start doing trigonometry, we have to remember we're dealing with a right triangle. So it's definitely important to point out that I have a right triangle that I just colored in yellow. And the height is one of the legs of that triangle. And in fact, it is the side that is opposite of this 34-degree angle. And I know the entire length of this 15, which is opposite of the 90-degree angle. That would be the hypotenuse of the triangle. This 20, by the way, is longer. It's greater than the just this piece of the right triangle. So so we can't use 20 in our work. So that means we're going to use opposite and hypotenuse, and so that's sine. So really fast now, you can do that. The sine of, well, it's 34 degrees is equal to the opposite side, which is the height of the triangle, divided by the hypotenuse, which is 15. And then we can just solve for the height by multiplying both sides by 15. And that's how you undo that divided by 15. And so the height of the triangle is going to be 15 times the sine of 34 degrees. Then you get out your calculator. You punch in, pardon me, you put it in degree mode, and you do 15 times the sine of 34 degrees. And just trust me, you get 8.39. So that means by using trigonometry, we're able to calculate that the height of the triangle is 8.39 units. And now that we know that, and we know the base is 20, we can find the area. We just had to use trig to calculate the height. So we could do 1/2 times 20 times 8.39. And what we're going to get there is 1/2 times 20 is 10, and 10 times 8.39 is 83.9 square units for our area. So again, what we had to do first, the first step was to just use trigonometry to find the height. And we're only able to do that because when you draw the height, you make a right triangle. And once we have the height, then we can find the area. Let's do it one more time, and then we're going to kind of generalize this. So, and if you want, you can pause the video and try it on your own. I think that's actually a really good idea. See if you can figure out the area of this entire triangle, but first we're going to have to figure out the height. And so now that you've paused it and tried it on your own, note that, again, if this is a 21-degree angle, the opposite side is the height. The 42 is this entire length here, okay? And that's actually going to be the base. So we're not going to use that, but the hypotenuse is this side here, the 34. And so it's going to be opposite over hypotenuse. And so I could start with the sine of 21 degrees is equal to the opposite side, which is the height, over the hypotenuse, which is this side that is adjacent, well, I should say next to the angle, right? That's the hypotenuse of that right triangle. And so we end up with a very similar equation to the one that we solved before. The sine of the angle equals the height over the other side. And so if we multiply by 34, we can find the height is 34 times the sine of 21. This one I don't have memorized, so I'm going to have to go back over here and open up Google Calculator. Not Google Translate. Sorry, bear with me. I'm not going to start this video over because of that. Okay, so we put it in degree mode, and I'm going to do 34 times the sine of 21 degrees. So, okay, 12.18. Okay, and that seems to make sense. 12.18. So now that I found that, I can determine that the height of the triangle is 12.18 units. And then I can go back and I can find the area of the triangle just using the area formula, which is 1/2 times the base times the height. And now I'm going to use 42 in place of the 1/2. And I'm going to use 12.18 in place of the height. And then I just need to figure out what that equals. 1/2 times 42 is 21. And 21 times 12.18 is, well, here, I'll just do 0.5 times 42 times, darn it, 12.18, 255.78 units. So hopefully that's what you got when you pause the video. 255.78 units, square units. So we did that a third time, and this was all in Desmos. And then I took everybody back to class, and I said, now let's generalize that, okay? Let's just imagine, because it's the same process both times. You use the sine ratio to find the height, and then you use the height and the base to find the area, pardon me. So let's sort of generalize that. And here I have a triangle, right, where I have angles capital A, B, and C, and then I have the sides that are opposite, lowercase a, B, and C. So I'm just going to sort of imagine if we're using this angle C here, right? B is going to be the base of the triangle, and then height is what we need here. And so notice that, and this is really important, side A is going to be the hypotenuse of this right triangle that we're going to use when we generalize this. Okay, so if side A is the hypotenuse, side B is the base, I want you to notice that sides A and B are the two sides that surround the angle that I'm going to use. I'm going to use angle C. And so I know that the area of the triangle is 1/2 times the base times the height. But again, if I sort of generalize that height there, I know that the sine of angle C, whatever angle C is in any triangle, is the opposite side, which is the height, divided by the adjacent side, which is, not adjacent, the hypotenuse side, which is always going to be this other side here that's next to the angle. Because the right angle is over here, and so it's h over a, right? A is, all, no matter what that number is, it's always going to be the hypotenuse. So if we just isolate the letter h by multiplying both sides by a, that means that the height of the triangle will always be the length of that side here that's not the base times the sine of the angle. And now we can just substitute that value in for, we can substitute that in, oh, darn it, in place of the height. So it would be a times the sine of C can get substituted in place of the height. And so then I said, okay, well, that means all we're really doing is 1/2 times the base times what we just did there, a times the sine of angle C. And when I'm multiplying everything, it doesn't matter the order. And so mathematicians like us, we actually prefer things in alphabetical order. So the actual formula that we always use is 1/2 AB, just reverse the A and the B, times the sine of the angle C. And I want you to really pay attention. A and B are the sides that surround angle C. Okay, so if I have a triangle and I don't know the height, but I do know two sides and an angle, as long as those sides surround that angle, I can find the area. This is a very important thing to note, so make sure you get it written down because we're going to use this a lot. We're going to use it in the next lesson. When we learn about the law of sines, we're going to use it in lots of other lessons. Okay, so let's just apply it to this, our first triangle, just to make sure. Remember the area of this triangle is 83.9. 83.9. Okay, so remember A and B are the two sides that surround the angle. So look, I know that there's a 34 degree angle there, and I also know the two sides that surround it are 15 and 20. So I could use 15 for A and 20 for B, and then the angle called C in our formula will be the 34 degree angle. So that means that really I'm just kind of repeating what I did before. 1/2 times one side, 15, times the other side, 20, times the sine of the angle that's in between them. And hopefully we're going to get 83.9. Let's check it on the calculator. Here we go. 0.5 times 15 times 20 times the sine of 34 degrees is 83.9. That's right. So you could, if you know the two sides, right, the two sides that surround the angle, you can use this new formula. And you can find the area of a triangle without actually knowing the height. If you know the angle but not the height, you can use this formula, 1/2 AB sine C. Good luck.